In this lesson, we're going to review scientific notation. Scientific notation is a way that we write regular numbers, just the standard normal way we write numbers that are extremely large, meaning they have lots and lots of digits. We write them with fewer digits. It's like an abbreviation. So with scientific notation, we are going to take a number, for instance, 280 million. Okay. Now this isn't a really big number, but it's just a good example for us to look at. That's 9 digits long. So that's the standard normal way we would write it. In scientific notation, we're going to shorthand or abbreviate. Okay. Guys, if I make notes, I want you to make notes on your paper as well. It's an abbreviated way of writing really large or really small numbers. So in scientific notation, it is written as a product of two factors. Product means multiply. So 280 million can be written in scientific notation as 2.8 times 10 to the 8th power. What this means, guys, we are going to look at a number to convert it into scientific notation. We do a couple of simple steps. We look at the first factor, the leading digit. Okay, the first factor can also be called the leading digit. This is the very first number that's not a zero that we see in a particular number. Okay, it has to be a number that's between 1 and 10. Okay, so we're going to underline that leading digit. Then our decimal is going to get moved to the right of it. Okay, now here is the one thing you got to do. If I look at a number and in standard form, regular form, we do not see a decimal, then we automatically place the decimal at the end, all the way to the right. Okay, so this is where the decimal is since they don't show it to us. So that means to put this number in scientific notation, I need to take this decimal and I need to move it between the 2 and the 8. I need to move it to the right of the leading digit. So I'm going to write down 2.8. We always are multiplying times 10. That's our second factor. It's always a power of 10. The exponent is going to be how many times we move the decimal from the end of the number to the right side of the leading digit. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 times. That's how we get an exponent of 8. Okay? Scientific notation. The exponent tells us how many times and in what direction to move the decimal. A positive exponent moves the decimal to the right. A negative exponent will move the decimal to the left. So let's look at how this works. Regular notation. If the decimal is moved left, the exponent will be positive. So that means starting here, I'm going to move it to between the 4 and the 2. I'm going to count 1, 2, 3, 4, 5 times. That's how we get a positive 5 over here. On this number, decimal is right here. I need to move it to the right side of the leading digit. I count 1, 2, 3, 4, 5, 6, 7, 8 times. Now, if we're going to move it to the right, our exponent is going to be negative. That means we have a really small number. Here's where you got to remember. The decimal's here. I need it to be on the right side of the leading digit, the first non-zero number. 1, 2, 3 times. That's how we get a negative 3. It's going to be right there between the 1 and the 4. 1, 2, 3, 4, 5, 6. So that's how we get a negative 6. Okay? Let's look at the second page here. Going in reverse. Positive exponent tells us to move this decimal to the right. So it was over here. So I moved it 1, 2, 3, 4, 5 times to make 750,000. 3.8, I'm going to move the decimal 4 times to the right. 1, 2, 3, 4. If it helps, you may want to write the decimal out here and physically move it. 1, 2, 3, 4, 5. And then you fill in zeros. 3.8. 1, 2, 3, 4. And fill in zeros. So we can see that those numbers match. When it's negative, the only difference now is I move to the left. So instead of writing my number on the left side, I'm going to write it closer to the right side here. I got to move it 3 times to the left. 1, 2, 3. That's my decimal now. I'm going to add 2 zeros. 7.51. 5 times. I'm going to move it 5 times to the left. There's my decimal. And I add, did I not count right? 1, 2, 3, 4. Oh, I made a mistake. This is why we need to show our work, guys. 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. Okay? Now, we're going to do a couple of these as practice. And then I want you to finish the practice, and there's going to be a second handout with additional practice that I need you to complete. Guys, scientific notation, the key here is repetition, doing it as many times as possible. So let's look at number 1. Underline the leading digit. I don't see a decimal, so I've got to put it at the end of the number. And I'm going to move it 1, 2, 3, 4 times to be on the right side of the leading digit. So it's 4.5 times 10. And I moved it 1, 2, 3, 4 times, 10 to the 4th. You have to write everything that's here in order to get credit. Let's look at number 4. Here's our decimal. That's my leading digit, so I need the decimal to the right. 1, 2, 3, 4, 5 times. So that means I'm going to write these non-zero digits, 3.78. It's always times 10, and I moved it 5 times to the right. So now it's a negative exponent. You're going to complete the rest of these on your own. Use the examples on both these pages to guide you. And you can always ask me or Mr. Caribou for help. To change from scientific notation to regular notation, we're just going to move the decimal, however many times it tells us to. If it's negative, start by writing your number over to the right side. And then I'm going to move that 6 times to the left. The negative sign is pointing to the right direction. So I got to move it 6 times. 1, 2, 3, 4, 5, 6. And just add 5 zeros. Let's come down here and let's do number 8. 9.7 times 10 to the 7th. I'm going to write it a little bit over to the left side because that's a big positive exponent. I just need to move it 7 times. 1, 2, 3, 4, 5, 6, 7. And fill in the zeros. Okay? What you're going to do, guys, complete the rest of this practice, and then you are going to also get this writing numbers in scientific notation handout, and it's additional practice. It's 30 total problems. Remember, guys, we're just placing the decimal, counting how many times we're moving it. We need lots of practice so that we can get these questions right 100% of the time. Ask for help if you need it.